Welcome again to my YouTube channel. In the previous video, I had covered the maturity indices of sugarcane, the properties of sucrose as the major component of sugar crystals, and the uses of sugar in our homes and industry. To get more information about this, kindly watch my video that I uploaded last week. Today, I'm going to cover pre-milling and milling as the first section of sugarcane processing. I have divided this topic to four subtopics, that is cane handling, cane preparation, juice extraction, and mill sanitation. I'll start with cane handling. Sugarcane is a perishable product. This because when immediately it's harvested, there are reactions that occur in this sugarcane which reduce its recoverable sugar and water. These reactions are: number one, sucrose inversion. The invertase enzyme present in sugarcane accelerates the breakdown of sucrose to fructose and glucose, hence lower the purity of this sugarcane. Number two, transpiration. Sugarcane continues to lose water to environment even after harvesting. Since it is not absorbing moisture from the soil, the lost water is not replaced. The loss of water lead to the reduction of cane weight, hence reduce the payment given to the farmers. The third reaction is microbial activities. Microorganisms like leuconostoc species, lactobacillus species, yeast, and molds enter sugarcane through cuts and injuries. Leuconostoc species convert sucrose to a polysaccharide called dextran. Dextran is not easily removed from juice during juice treatment, hence finds its way to the materials at pan boiling section. The presence of dextran in materials increase its viscosity, hence reduce the rate of pan boiling and crystallization. Dextran also causes the formation of irregularly shaped crystals. Irregularly shaped crystals and highly viscous molasses increase time needed for centrifugation. Lactobacillus species convert sucrose to lactic acid, hence increase the acidity of juice. High acid accelerate sucrose inversion. High acidity also force the operators at clarification center to add more lime to boost pH. The addition of more lime leads to high chemical cost. Yeast and molds also reduce the purity of sugarcane by anaerobically breaking down sucrose to alcohol. Since sugarcane is at high risk of losing its quality and quantity, it has to be handled properly in the field so that the factory can optimally extract sucrose from this sugarcane. The practices that have to be applied in the field for efficient handling of sugarcane is: number one, the harvested sugarcane have to be transported within 24 hours. Number two is harvested sugarcane should not be exposed to sunlight for a long period of time. This because high temperature accelerates the growth of microorganisms and enzymatic activity. Then number three, cane handlers should avoid injuring of sugarcane. Remember, I've informed you that microorganisms enter sugarcane through cuts and injuries. When the lorry or tractor reaches at the factory, it is weighed first before sugarcane is offloaded at cane yard. The weight of lorry plus sugarcane on it is referred to as gross weight. After offloading, this lorry or tractor is weighed again. The weight of the lorry is referred to as tare weight. To get the exact weight of the sugarcane that has been brought to the factory, we'll take gross weight minus tare weight. Weighing is important at the factory because it will enable the factory to know the exact amount of sugarcane that has been brought by the farmer, hence determine the amount of money the farmer can get in return. Some factories also pay transporters as per the number of trips and tons brought in the factory by this transporter per day. At the cane yard, sugarcane is offloaded from the tractors or lorries by cranes, caterpillars, high-low unloader, or people. The person in charge of cane yard is supposed to apply the rule of first come, first milled to avoid overstaying of cane in the yard. Stepping on cane by vehicles and chewing of sugarcane has to be avoided to minimize losses. Sugarcane from the floor of cane yard is loaded to the feed table by cranes. Feed table is used to load or to feed sugarcane to auxiliary cane carrier. Feed table has drag chains which drag sugarcane to the auxiliary cane carrier. The feed table also has a kicker. The function of the kicker is to balance cane being fed to the cane carrier. Cane carrier is normally used to transport sugarcane through the preparation devices. Immediately sugarcane is loaded on the auxiliary cane carrier, that's the end of cane handling. Now we start cane preparation. Sugarcane is majorly made up of the hard cover called rind and the inner part which has cells that hold juice. So the main objective of milling is to extract as much as possible of juice from the sugarcane. So for efficient extraction, this sugarcane has to be prepared by breaking the rind and rupturing and opening the cells holding juice. The preparation of sugarcane is done by the following devices. Number one, you have the kicker. The kicker normally balances the level of sugarcane on auxiliary cane carrier. The cane carrier take sugarcane to chopper. The chopper has 42 revolving knives which cut whole cane to small pieces. It revolves at a speed of 360 revolutions per minute. The small pieces of sugarcane are transported to the leveler by cane carrier. The leveler has 56 knives which reduce the small pieces of sugarcane to smaller sizes. The leveler revolves at a high speed of around 600 revolutions per minute. These smaller pieces of sugarcane are again transported to the fibrizer. Fibrizer has around 128 hammers. These hammers crush the pieces of sugarcane against the wall, hence opening about 95% of cells holding juice. Shredded cane from fibrizer is transported by the fiber rake carrier to the conveyor belt. Conveyor belt has a magnet which trap any metallic object present in the shredded cane. The conveyor belt drops the shredded cane to the chute. Function of the chute is to evenly distribute shredded cane to the mills. The cane preparation ends at the chute feeding. Now we start juice extraction. Mills have a set of rollers and each set has 3 rollers. That's top roller which rotate in clockwise direction, and its function is just to control the rotation of other rollers. Number 2, we have feed roller. The feed roller receive bagasse, and bagasse is squeezed between feed roller and top roller. Feed roller drop bagasse to the shredded cane to discharge roller. The discharge roller does the final squeezing and drop the screen bagasse to the intercarrier. These rollers are arranged in a triangular set so that it can squeeze sugarcane twice under pressure. 4 or 6 sets of rollers is referred to as crushing tandem. A factory can have 4 sets or 6 because the first mill only extract 65% of juice, and the cane residue is transported to other mills to extract the remaining juice. Under the rollers, we have a device called trash plate. The function of trash plate is to prevent bagasse from falling on juice tray. Also, trash plate is used to remove the bagasse from the grooves of feed roller. The grooves on roller have the following function. Number 1, they assist in gripping or holding prepared cane. Number 2, they break up cane at each squeeze, hence opening more cells. Number 3, the roots of grooves provide drainage system for the juice. Juice extracted at mill 1 is referred to as primary juice or first express juice. This is because it's the original juice that is removed from the sugarcane. There's no water added to the shredded cane. As screen cane move from mill 1, juice extracted from mill 3 is evenly sprayed on them to make it wet for better extraction. This screen cane is then transported to mill 2 by intercarrier. At mill 2, more extraction is done whereby the rollers squeeze the screened cane and remove juice. The juice from mill 2 is referred to as secondary juice. This because it is diluted by imbibition water. Juice from mill 1 and mill 2 is the only juice that is mixed, pumped to rotary screen filter to remove bagasse, then pumped to mixed juice tank. After that, it's weighed and transported to juice treatment section. As bagasse move out of mill 2, juice from mill 4 and hot imbibition water is evenly distributed on them. Hot water is used because hot water dissolves more sugar than cold water. Water of above 80 degrees Celsius is not used because hot water can dissolve waxes present in fiber. And remember, we don't need waxes in our juice. This screened bagasse is then transported to mill 3 for further extraction. The juice extracted at mill 3 is pumped to mill 1 for imbibition. As bagasse move from mill 3, hot water is evenly distributed on them to absorb more sucrose and dry this bagasse. This bagasse is then transported to mill 4. At mill 4, final squeezing is done, hence producing juice which is pumped to mill 2 for imbibition. Bagasse from mill 4 is transported by bagasse carrier partly to boiler and another one to the yard. Bagasse is used as fuel at the boiler to produce heat, which is used to boil water producing steam. This steam is used to run turbine which generate power. The remaining bagasse can be stored to be used for another day or can be used to make briquettes. Briquettes are charcoal that can be used for heating or can be used in other factories. For efficient working of mill devices, the operators have to observe the following factors. Number one, mill setting. Setting of the openings between the rollers and the position of trash plate is important to make sure that mills work as originally designed. Number two, there should not be bypassing of joists for inhibition. Number three, sufficient pressure has to be applied on top roller. Remember, top roller is the one that control the rotation of other rollers. The next one is loaded cane should have less trash and dirt. This because high extraneous matter in sugarcane accelerate the wearing of knives, hammers, and the rollers. And finally, maintenance of rollers, hammers, and knives should be done frequently. That's the end for mill extraction. The last subtopic is mill sanitation. Mill sanitation entails the cleaning of mill devices with chlorine and water. After applying chlorine on the surfaces, these devices have to be cleaned thoroughly by water. Remember, chlorine, when it is dissolved in water, it forms hydrochloric acid. Hence, if it's left on the surface, it will raise the acidity of the juice. Under mill sanitation, you also have application of biocide on extracted juice. Biocide is just an agent that kills microorganisms present in the juice. The chemical name of biocide is sodium dimethyl dithionocarbamate. Biocide is majorly used at mills because it cannot be used at a stage where microorganisms has grown optimally. Also, above 80 degrees Celsius, biocide can decompose to non-toxic gases. That's the end for pre-milling and milling. In our next video, we will cover juice treatment as the second section of sugarcane processing.